Hello and welcome back to Drilling Sessions. Today we are going to discuss one of the fundamental concepts of programming in C++, data types. Understanding data types is crucial for anyone looking to master C++ or any other programming language, as they form the building blocks of code. Let's get started. First, let's answer a basic question. What exactly is a data type? Think of a number. Which is your favorite? According to The Guardian 2014 survey, the world's most favorite number is 7. You already know what kind of operations can be performed on numbers. You can increase it, decrease, multiply and divide. You can also read it, write it, spell it, etc. And all this set of information came out of a single word: number. Now, imagine a dictionary. Just by this single word, you already understand that this is a collection of words, probably alphabetically sorted with the translation into another language, or some other data, depending on the type of the dictionary. You already know which set of operations are allowed for the dictionary. You can basically just search for a specific word. It can be done easily by looking for a word in the content of a dictionary. In both cases, you understood the type, amount of the data and the set of allowed operations just by a single word that described it. In programming, a data type is an attribute of data which tells the compiler or interpreter how the programmer intends to use the data. It defines the operations that can be done on the data, the type of values it can hold, and the amount of space it occupies in memory. It helps us ensure that our programs use data efficiently and correctly. They also help manage memory usage, which is crucial in large-scale software development. In C++, data types are broadly split into three categories: built-in, derived, and user-defined. Built-in data types include the fundamental types like int for integers, char and WHRT for characters, float and double for floating point numbers, bool for boolean values which represent true or false, and void for value absence representation. Next, we have derived data types. These are formed from the built-in data types and include arrays, pointers, references, and function types. They allow more complex operations and data structures to be built from the simple ones. Finally, user-defined data types allow programmers to build their own data types. These could be structures, unions, classes, enumerations, and type defs. User-defined types are powerful tools that help manage complexity in large programs by allowing programmers to bundle related data and operations together. Let's try to simulate a custom data type creation scenario. Imagine you are taking part in supply chain software development. Here is a short list of objects we will likely work with: a client, a warehouse, transport, and of course a delivery package. A client object may contain client name, age, address, and some unique ID. A warehouse most likely will contain address, working hours, and capacity. There may be several different types of transport: a ship, a plane, and a truck, for instance. Each of them will contain an array of goods, speed, and maybe a price per hour. The delivery package should contain source and destination address, client link, weight, and additional information about the content: fragile, liquid, refrigerated, etc. While it's very far from the full and efficient design of supply chain software, this should give you an idea how the data types are being created and bundled. It's not mandatory to create all these data types. We could have worked with all those names, addresses, prices, cargo types separately. But this is another benefit from correct data type creation. At the end of the day, it's easier to work with a delivery package object that contains all relevant information inside, than drowning in the ocean of addresses and client IDs. That's all for today's session on data types in C++. In our next video, we'll dive deeper into each type, exploring their specifics. Thanks for watching and happy coding!